The last thing we're going to talk about here in chapter 5 then is symmetry. And you've seen symmetry before. We're going to look at this again and talk about line symmetry and rotational symmetry. So copy on your target, and I just, put a slide up here to start us off just thinking about, is math beauty or is beauty math? Because there's a lot of people who say that math is naturally found attractive. There's certain numbers such as the golden ratio, which if people were given two options, they would choose that the golden ratio is more attractive. So there's a lot of art and architecture that when things are being built or things are created, they have this golden ratio, which is a ratio is a proportion. So, a ratio is half of a proportion. So, like the length to the width. It has this certain ratio that we just naturally find attractive. Think about the Mona Lisa painting. The Mona Lisa is one of the most well-known paintings, and some people like to stipulate that Mona Lisa's face has the golden ratio in it. When you divide the height by the width, you get this value of about 1.618, which is the golden ratio, which we just naturally find attractive. Also, people find symmetry attractive as well. You think about symmetry, a lot of people will say that the more symmetrical your face is, the more attractive you are. Or even looking at a building, people like to design architecture that has symmetry because we find it naturally attractive. So it's just something interesting to think about. We're going to focus on line and rotational symmetry, but look around when you're driving down the street or when you're at home. Look at your house. Does your house have symmetry? Does the front of your house have symmetry or not? So line symmetry, you can draw a line through the figure so that two sides are mirror images of each other, and the line is called the line of symmetry. So please make sure you write that down. Whatever you're reflecting it over to get it to land on itself would be the line of symmetry. So in this picture I could draw, and the bird would be split in half, and if I reflected it, if I folded this side over to that side, it would land on top of itself. Same with the butterfly here, we could divide this. Very symmetrical. I could fold it and this wing would land almost right on top of that wing. Taj Mahal, so here's an example about architecture. We can see that a lot of architecture has symmetry because we like how it looks. It looks pretty, it looks good. So the Taj Mahal is a great example of line symmetry. A figure can have rotational symmetry if you rotate the figure around a point so that it coincides with itself, and the point that the figure is rotated around is called the center of rotation. So I have, flowers and honeycombs and snowflakes up here as examples, but when you rotate them, it would land on itself. And I want to show you a picture of this just to make sure you understand it. So if you look at these two pictures here, let's look at this first figure. You have this S-type figure. This line's up here. It's going to turn, and we're going to see how many times it lands on itself within one rotation. So once this black line gets back up there, how many times will this S have landed on itself? So let's see. There's once, and there's twice. So this would have an order of 2 because it lands on itself twice in one full rotation. Let's look at this one. Make a prediction about what the order would be of this image. Once it makes one full rotation, how many times will it have landed on itself? The key thing is not to count the starting point and the ending point as 2. That's going to be 1, okay? So they don't count the first one, but they'll count it when it gets back to this. So let's see. 1, 2, 3. So this would have an order of 3. Rotational symmetry is going to have a center of rotation. We'll practice that. And there's a couple examples that we would see in nature that you could rotate and it would land on itself. When we think about this starfish, if I rotated it once this end got there, that would be 1, 2, 3, 4, 5. So this would land on itself 6 times in one full rotation. And again, it's not. You might look at this and say, well, it's not exactly perfect, but you see what I'm talking about there. So let's practice line symmetry first. In example 1, I just want you to complete the figure. The dashed line is a line of symmetry. Draw the other half so that this would be symmetrical. When you're drawing these, do the best that you can. Use a straight edge if you have one. If you have the edge of a book, you want to make your lines nice and straight. Each vertex should be the same distance from the line of symmetry on either side. So this red vertex is about this far away. I'm going to draw it about the same distance on the other side. This blue vertex a little bit closer. It's going to go straight down over that line, and it's going to be a little bit closer. So I'm going to put it a little bit in from the red. This green vertex on the same distance as the blue. So these look pretty lined up. And then the light blue vertex is on the line of symmetry. So when you reflect it, these points would just stay where they are. Now, once I have my vertices, I find it easier to connect. So go ahead and connect. And there's your completed figure. That looks symmetrical, and the line you can see is where it folds and it's even. Try the second one. Again, I like to find the vertices distance first. If you have a ruler and you use it, that's even better. So over here, and straight across that line of symmetry. And then this is going to dip into about here. So just do the best that you can with this curve. It doesn't have to be perfect. But there we go. That's pretty good. That looks pretty symmetrical. Try the letter one by yourself then. Circle which letters have lines of symmetry and draw in the lines of symmetry that they have. Some will have one, some might have two. So pause, circle all the letters that have line symmetry, and then press play to see if you got them all right. So most of these letters have line symmetry. A all the way to E has line symmetry. H and I have line symmetry, and so does K. So A, B, and C, and D, and E all have one line of symmetry that you could draw, and it would land on itself. H, though, has two. You could draw one line going down vertically and one line going across, so it would have two lines of symmetry. Same thing with I. I could cut I in half horizontally, or I could slice I right down the middle vertically. So two lines of symmetry here. And the last one, K, just one straight across. So lots of symmetry in our alphabet. Let's look at some examples of rotational symmetry. We're going to practice trying to draw rotational symmetry. Remember, like the video I showed you, it's going to rotate around in a circle. The point that's the center is called the center of rotation. So the point they're giving us is the center. We're going to rotate this so that it has two-fold, or an order of two. And now you think about it, the whole thing's going to rotate in a circle, right? And this is my center. Well, how many degrees are in a whole circle? There are 360 degrees in an entire circle. If this is going to land on itself twice, how far do you have to turn it before it'll be the other part of the image? Well, if there's two-fold, just divide 360 by 2. This figure will land on itself every 180 degrees. So now that we know that, we can just take what we see and rotate that image 180 degrees. So here's my center right here. Notice the distance of your vertices from there, and you're going to rotate it 180 degrees, which we learned is like flipping it on a line, right? So this is going to turn, this slice is going to turn all the way to be vertical again. Notice that the center is a little closer to the shorter end, a little farther from that other end. So when it rotates, the farther piece will rotate up to the top, which means this vertex will be a little bit farther away, and the shorter piece will rotate down to the bottom. So this side won't line up exactly with each other, but that's okay. Let's look at another point. Okay, we're going to rotate this, and it's going to make an L, so we know that these are going to go out, because the shape will stay the same. This side rotated, oops, I think I drew it the wrong way. The long end will rotate to the top. So I need to erase that line. And the skinny end will rotate to the bottom, so there's the skinny end. You can kind of take this up then, and then we're going to take this out to about here. This image would have a two-fold, altogether as one image, this would have a two-fold rotation. I would rotate it till it lands there, that's once, and then till it lands there, that's twice. Let's try another one. If it has a 5 folds of symmetry, I like to think about how many degrees does it need to turn before it'll land on itself. Well, remember there's 360 degrees in a circle. Now in this one, we're going to divide it by 5. So the figure will coincide with itself every 72 degrees. So when I look at the center, if this is going to rotate and it's going to land on itself 5 times, from the center I need to have basically 5 wedges coming from it, right? And each point's rotating about 72 degrees, so a little less than 90 degrees, or a little less than a right angle. So I'm just going to approximate these right here. And that looks pretty good. And now we'll just take the points out, and we're just, we're doing the best we can with this. So keep the distance the same. If you can measure out, if you have a ruler, that's going to be even better. So this distance should match this distance, and then you can connect them. This distance should match this distance. If you have a compass tool, you could even draw a circle around it, and that would also help you. But you don't need to be that specific here. We're just practicing drawing general ones. So it's like a sketch. There we go. That star has 5-fold symmetry. I could turn it 5 times and it would land on itself in 1 full rotation. All right, try the last 2. Try this. Try one of each, a line symmetry and a rotational symmetry. Press play when you're done. I want you to pause and try it on your own. Plus play when you're done to check it. Please pause and try these now. All right, so let's see how you did. Here are my 2 pictures. Hopefully yours look very similar. The top one has line symmetry. The second one has 4-fold rotational symmetry. Nicely done.